Okay, guys, I promised a couple of example problems. This is one of the preparation problems in Unit 1. The preparation problems give you the entire table that they want you to figure out. Now, these underlines are because the numbers are different for each individual person. These are the values for the Joe Bulldog account. Okay, so starting off, we're initially traveling 12 feet per second. That is the initial speed, 12, and for this problem, it's feet per second, which is okay as long as we have everything in feet and seconds. Steadily speeds up to 74 feet per second, so that is the final speed. 74 feet per second in 4.8 seconds, so that is the time. Determine all unknowns and answer the following question. Now, if you've noticed, one of these questions are usually just one of the unknown values. Okay, so the deal here is that we have the initial speed and the final speed and the time, and we would like the average speed and the distance covered. Well, to get the distance covered, we need the average speed. Well, luckily for us, as long as you speed up or slow down at a steady rate, steadily speeds up, then your average speed is simply equal to your initial speed plus your final speed divided by 2. It's a simple average. So that's 12 plus 74, and both of those are feet, divided by, oops, I almost put the time down there. That's a different thing. I was thinking about acceleration. Just divided by 2. So let's see, 12 plus 74 is 86. Half of 86 is 43. So that is 43, and that is, those are feet per second, I apologize, feet per second over here. 43 feet per second. Now we can find the distance. Since average speed is equal to distance divided by time, if I want the distance, I multiply both sides by time, so it's average speed multiplied by time. The average speed was, of course, 43 feet per second, and the time was 4.8 seconds. I'm not going to do that one in my head. 43 times 4.8, and we get 206.4 for how far they went. He likes 3 sig figs, 3 digits in all of his answers, so I'm going to put down 206, which is the same thing as up here, 206, and that was feet. All right, real quick, I'm going to plug them into, well, I'm going to plug at least the last one in to positive physics, just to make sure that we didn't make a mistake anywhere. It's green, so we're all good. All right, let's move forward from the preparation problems over to a couple of the complete problems. Notice on the complete problems that we no longer have a table. That doesn't mean it's different. It's the same thing. Okay, so for this one, a bicyclist steadily speeds up from rest. Okay, now I'm going to do this one with a guess process, and I'm going to remind you of what guess means. The G, all right, so anyway, let me spell it out first. All right, the G is list out your givens, okay? And then identify what is the unknown or unknowns. Okay, what are your givens? What are your unknowns? What's the equation that you're going to use? And then if the equation isn't solving for the right variable, then you need to solve, and that is for the unknown. All right. And lastly, we substitute. What do we substitute? We substitute in the givens. All right. And then, and only then, we grab a calculator. And when you guys are showing your work, I expect to see these things. So let's demonstrate the usual process over here. Okay, first of all, they said it started from rest. So that means my first given is that my initial speed is equal to 0. it goes up to 11 meters per second. So that means my final speed is equal to 11.0 meters per second. In 4.50 seconds, because I recognize what seconds represent, I know that that is my time. 4.50 seconds. And then we say what they want. How far did she travel during this time? So D equals question mark. All right, so that's the summary. That is writing down my question. Really, that's it. Now we're solving for things. Now D, I've only got one formula for D at the moment in positive physics. We did introduce a new one in the Hewitt-Druitt. The distance is equal to my average speed multiplied by my time. Now, this is already solved for the distance, so I don't need to rearrange that and solve for the distance. Problem is, I need an average speed. So I've got to have a second equation. My average speed is equal to my initial speed plus my final speed divided by 2. So that's 0 plus 11 meters per second divided by 2, and I end up with 5.5 meters per second. Okay, now I can finish off this problem. I go back up here. I go 5.5 meters per second being multiplied by 4.50 seconds. And this is the point at which I grab my calculator. Now, I could have grabbed my calculator here, too, because I got to that point in that part. And 5.5 times 4.5 gives us 24.75. He likes 3 significant digits, so I'm just writing down 24.8. And it's going to be meters per second. Then it's multiplied by seconds, so the seconds cancel out, and we're left with meters, which is, and that is what goes over there. I want to look at 2 more real quick. This guy right here is a trick question. A student releases a marble from the top of a ramp. The marble increases speed while on the ramp, then continues across the floor. The marble travels a total of some number of centimeters in some number of seconds. What is the marble's final speed? They gave you enough to figure out the average speed. But the final speed cannot be determined from the average speed because it didn't speed up at some steady pace. It sped up at different rates. It sped up more here than it did over here. And it actually slowed down in this segment here. This question has no answer. I don't remember what their phrasing is for it. What is their phrasing? Cannot be determined. Okay, go on to one last one here, and then I will call it quits, and I'll publish this on the website. Okay, a rocket initially at rest steadily gains speed for 4.7. Wait, initially at rest, speed initial is equal to 0 for 4.70 seconds. That is my time. While traveling upwards 40 meters, that is my distance. That's the important stuff that was in my problem. And then they want to know what is the final speed. So the final speed equals question mark. Now, I'm not writing them all down because they're in front of me. If you ever want to print out any of these pages, you are welcome to work on the pages and not have to do the whole guess process. It just saves you from step 1 and step 2. Now we need an equation. We're trying to solve for final speed. The only thing that we have with final speed is that formula for average speed. Average speed is equal to initial speed plus final speed divided by 2. We're going to solve this for final speed. But we can take a shortcut already because they said the initial speed was equal to 0. So clearing that out of here, we've just got that average speed is equal to the final speed divided by 2. And we'll multiply both sides by 2, giving us that the final speed is equal to 2 times the average speed. So, and we need to now stop and figure out our average speed. Our average speed was distance divided by time. My distance was 40.0 meters. My time was 4.70 seconds. So calculator time, 40 divided by 4.7 is, it's definitely not 10. 40 divided by 4.7 is 8.51. And that's going to be meters per second. So my final speed is 2 times 8.51. Yeesh, that's supposed to be a 1. Meters per second, which that one I can do in my head. That's going to be 16 plus another 1.2, so that's 17.02. 17.02, which I really should just write as 17.0, and that's going to be meters per second for our final speed of our rocket, and that's it. Okay, so good luck with those things. They're not that bad.